In this video, I'm going to teach you how to perform data analysis in Chat GPT using a college football use case that you can follow along with. Hi, I'm Brian Amrine with Value Driven Analytics, bringing you at least one video per week on analytics, data science, leadership, and yes, even sometimes Chat GPT. And that's exactly what we'll be looking at today. But before we do, if you want to follow along, I'm going to show you how you can download the dataset that we'll use in today's data analysis use case. Well, here we are on valuedrivenanalytics.com, and the first thing you want to do when you get to the main page is go to the Analytics Training menu, and under the Intro Data Analytics Training Series, check it out if you haven't already, but we're in particular today going to go to Session 3, Intro to Power BI. See, in our Power BI training series, we also did a college football use case, and so today we're going to use that very same data set. Just go ahead and scroll down. We'll have a Power BI dashboard that we created in our Power BI training session that we can actually check ChatGPT's analysis against. You know, when you're at a company, it's always nice to have another data source that you can compare your results to. That's a great type of validation check. If the data already exists somewhere else, compared to it, if it matches up, great. If not, you might want to look into that. So we might come back to this, but for now, let's take a look and download this collegefootballgames.xlsx workbook. Just click on that, it should download. And before we go over to ChatGPT, let's just go over to Excel and take a look at this data set. Well, here we are in Excel. Now what you'll notice about this data set, first and foremost, is there's a season column, and you can see it starts with 1936. And if we scroll down, you'll see games all the way through 2023, roughly November, October timeframe. So it was taken maybe mid to late season, the snapshot was. And this data set, I believe we cover this you can learn more about this in the Power BI training, was taken from a Python script, uses a college football API, and loops through and grabs all these football games, again, going back to 1936. So we've got a data set here that's one row per game, and I'll expand the columns here so we can see the titles. It tells us whether it's a regular or postseason game, has the start date, just the date of the game, the home team's conference division. There are some non-FBS divisions in here, but FBS is the division that's consistently populated. Some of the others have just been added for recent years, so keep that in mind, as we'll probably see when ChatGPT analyzes it. There might be some data cleaning needed here. We'll see how ChatGPT does with that. Well, it also has the home team, of course, and then it has the away team's conference, division, and team name as well. And we have the number of points scored by the home team and the away team, the attendance, which is very sparsely populated. It's not populated at all for these early games, but it tends to be populated a little bit, maybe starting around 2012 or so. City-state, which I believe just simply represents the city-state of the home team. It's not necessarily where that game was played. It was played off-site, and it's not always populated as well. And then a date of last refresh, so very helpful. I guess this was refreshed on October 19th, so there we go. So that's our data set. Now let's head over to ChatGPT and see what ChatGPT comes up with when we ask it to analyze this data set. All right, here we are in ChatGPT, and I want to mention that I am on the Plus plan. It includes advanced data analysis, so this may or may not be available on the free version. I'm using ChatGPT 4, which is also currently available on the Plus plan as well. I'm going to start out with attaching a file. Now, this is important. Do not include personal information or sensitive company information. Pretty much any company data you don't want to upload, unless you talk to your IT team, you talk to your manager, and you're on the enterprise plan where your data is not used to train ChatGPT. That's very important. Do not use even the Plus version. There might be some settings to avoid using data you upload to train, but I would still be very, very sure about that. Talk to your IT team, talk to your manager, make sure it's okay. But honestly, I would just do this with publicly available data, which is what we're working with now. This is publicly available college football data. Now just go ahead and hit the attach button here and navigate to where the file that you downloaded from valuedrivenanalytics.com was saved. All right, that file shows up in the top left here. And now we need to tell ChatGPT what we want it to do with it. With any ChatGPT prompt, the more information, the more details you provide, the better response you're going to get. But I'm kind of curious, what happens if we just give ChatGPT a very high level prompt? What will it come up with? This is very realistic of how a analyst stakeholder relationship sometimes goes. Sometimes you get really specific instructions and the stakeholder gets exactly what they want. And there's other times where the stakeholder maybe knows they need an analysis done, but they don't exactly have an idea of what exactly they want to do. I'm sure many analysts have experienced this. Can you just do some analysis on this? And you're wondering, what kind of analysis? What do you want to look at? What do you want me? What's the purpose of the analysis? And those are good follow-up questions to ask, in a polite manner, of course. Sometimes stakeholders, though, appreciate someone who kind of knows the business and they just get it. They say, yeah, we'll start by just generally analyzing the data set, seeing if I can find anything interesting that stands out. I'll send you some findings and we can go from there. Maybe you know what kind of challenges they're facing, and so you start analyzing the data in a way that's intended to address those challenges. That is a very talented analyst that will stand out from other analysts who simply wait to be told exactly what to do with the data. So we'll start out and see if ChatGPT is that kind of analyst. Can they take this file and just give us some insights straight away? Here is a file we'd like you to analyze. Let's just see what it comes up with. All right, I'll start by examining the contents of the file to understand what kind of data it contains and how we can analyze it. Let's open the file and take a look. That sounds great. You can see it's analyzing. Now, ChatGPT will take a little more time to analyze a file, probably depending on the size of the file, than it typically does for your generic word questions when there's not a data file involved. So you can see it's taken a little time here. Okay, I just got a message saying there was an error analyzing, and it's saying that the loading of the file took too long, and it could be due to the size of the file. I think there were about 70,000 games or so in the file. So it's fairly large, but man, there are certainly a lot bigger data sets out there. I'm a little surprised that it wasn't able to handle this much volume. I wonder if the enterprise version might have a little bit more computational power behind it. And there are other ways to interact with ChatGPT. You can actually interact with the Chat GPT Python API. Maybe we'll do a future video on that. So that could be an option if you've got access to the enterprise version. Now, it did recommend an alternative. Another great thing, if you're the analyst, for you to do, if a stakeholder comes to you with something and you say, you know, this file's too big, or we can't do that for whatever reason. Again, the more flexible analytics tools you have, if you know SQL and Python, pretty much sky's the limit from a methodology perspective. But if there ever is something that you just can't do, offer an alternative. And that's exactly what ChatGPT did here. So even though I'm a little disappointed about the size it's able to analyze here, I am happy that it just went and tried an alternative, and it tells me that as well. To proceed, I'll try a different approach by loading only a portion of the file to get a glimpse of the structure and contents. Let's attempt to just read the first few rows to avoid the previous issue. Now, after that, there's this View Analysis button. Let's click on that and see what happens. Okay, up pops this. If you've used Python, if you've taken our video on Python or you've learned Python elsewhere, this will look familiar. It's using the pandas package to analyze this file. It's reading it in, and it's using data.head, which looks at the first 5 records. And, you know, we've got the Python code right here. So ChatGPT uses Python for its data analysis. In every step here, we're going to be able to click on that and view the Python code if we want to. And we could even copy the Python code. So I suppose if it gets too big, we could potentially copy this into Python. And if we've got something else that can analyze it more memory perhaps, or just more compute power in general, we might be able to remove the parts that ChatGPT has potentially sampled down the data with. Um, so it's nice to have access to the code here. And we want to check this as well. Check the code. Make sure ChatGPT didn't make any errors. This is pretty straightforward here. Just imported the data set and then used data.head. Well, let's see what it comes up with here. It's telling us that the file contains historical data on college football games. Well, I think the file is called college football games, so I can see where it would get that, including the following columns. And it lays them all out. Now, this is cool. It's basically giving us a data dictionary for each column, and it's a machine. That's pretty impressive that it's able to do that. So, season is the year the game took place. So, it's able to take a field like season and understand that it's the year the game took place. That's pretty interesting. Now, I wonder if that's actually true though, because sometimes the season's 2023 and the year and the game actually takes place in 2024 if it's maybe a late bowl game or national championship. So, all right, it's pretty good for a machine, but maybe not always accurate. And we have an indication of whether the game was part of the regular season or postseason event. That's pretty good. It's looking at the data probably and seeing that there's two values there and interpreting them as regular and postseason. And you can read the rest of it as well. Pretty decent data dictionary. Again, maybe not always perfect. Pretty good for a machine, though. That's probably what ChatGPT thinks of me. That analysis is pretty good for a human. So let's see the final summary here. This data set provides a comprehensive view of college football games, including the details of the team, scores, and game locations. And then it asks us a question, much like we would for our stakeholders. Okay, here's a general summary. What would you like for us to do with it? How would you like to proceed with this analysis? Are there any specific insights or summaries you are interested in? Okay. Well, let's say we want to understand, figure out what the best conference is. A hotly contested topic on many forums. So we'll ask, which conference is the best? Now, we should probably be more specific and say which one has the highest winning percentage or winning percentage accounting for strength of schedule. Be a little bit more specific than the best. Which one has the best mascot? What do you mean? So that would be advised, but I'm kind of curious what ChatGPT is going to do with this. Again, very similar before, a very vague question. Can it make some sense of it? Will it ask us clarification questions? Let's find out. To determine which conference is the best based on the provided dataset, we can analyze the performance of the conference in various ways. One common approach is to look at the win-loss records of the teams within each conference. However, considering the dataset might contain historical data over many seasons, we could also consider factors like win rate, okay, points scored. The average points scored by teams in a conference could indicate offensive strength, right? Points allowed, the average points allowed by a team in a conference could indicate defensive strength. Championships won. Yeah, those are decent ways. I'm a little surprised that it didn't use point margin here because that would factor in points scored minus points allowed. What's that average point margin? That'd be a pretty good way to assess a team as well. Probably better than looking at points scored and points allowed separately. Again, unless you just focused on looking at the offense and defense separately. Um, so let's proceed with this analysis. Uh-oh, another error. It appears I made an error. At least it takes accountability for it, right? Not every analyst or not every employee in general takes accountability always. Attempting to use the data frame, which was defined in the previous cell that encountered an execution timeout, and thus the data frame wasn't actually created in the current context. Let me correct this by loading the data again with the appropriate adjustments, and then I'll perform the analysis to determine which conference is the best. So it's a very iterative approach. It's telling us exactly what it's doing. And it looks like another link to an analysis, which is really a link to Python code. Now, one thing to note here is it is not importing the data. It's not showing the import data here. So this code really applies to this step, and it is built on the previous code. It's assuming that the data is imported because that was included in the prior step, prior question we asked. So this is the code to add to the previous code. That's important to note. Let's see, adding a win column for home and away games. And so it checks to see if home points is greater than away points, and then it also calculates it from an away perspective. Is it an away win if the away points are greater than the home points? It looks like it's using the group by function from the pandas package, and it's grouping by the home conference first. It's getting the number of games played, which is what size does here against, could be any column, I think, the home conference here. And then home win, it's adding up the number of wins from the home team's perspective and averaging the home team's points. All right, and it's doing the same thing, it looks like, from the away conference's perspective. It's using pd.merge to bring these and the merge function from pandas. It's joining on conference, home conference equals away conference, add or join. Okay, so then you end up with these fields for the home team and the away team. It calculates the total games by adding the home games with the away games, and then it calculates the number of total wins by adding the home wins for that conference to the away wins for that conference. Okay, I'm following so far. It calculates the win rate, okay, by getting the total number of wins divided by the total number of games. That makes sense. And then it calculates average points scored by, let's see, ah, it looks like it's doing a weighted average here. Very good. All right. Well, it seems pretty robust so far. It's going to select relevant columns. It looks like it's cleaning up the data frame a little bit here. Renaming, renaming. Wow, it knows what to name things even. Home conference, and it's going to call that just conference in general. That makes sense since we're talking about the conference in general from a home and away perspective. And then it's going to sort them by win rate. The conferences by win rate. Very good. And then it's going to display the, looks like the top 5 records here. Wow. If you watched our Power BI training on this, you know that one of the things we needed to do was to, our approach was to union the games with itself and create columns from a home team perspective and an away team perspective. Because if you just group by home conference and calculate the average points and the average point margin and winning percentage, you're just going to be considering that conference's home games and not their away games. So ChatGPT realized that and has taken a different approach here, realizing that they need to calculate it from both a home team and away team's perspective. They bring it together and then they calculate some weighted averages that combine the home team's game, the conference's home games and the conference's away games together. That's a very clever approach too. I'm I'm impressed that it was able to figure that out without being told that to do that specifically. It knows that when you look at a game's data set, you need to consider it from a home team and away team perspective. That's pretty cool. Now, I would imagine there could be some use cases where it doesn't know all the context. But for college football analysis, it's doing pretty good so far, at least from a coding perspective. So it says it stopped analyzing here. What's that all about? And then there's this option to regenerate. I guess that's our option, right? Is to click regenerate and hope that it does a little better this time. Well, when I clicked regenerate, it gave me slightly different text this time at the top. It still talks about figuring out which criteria is going to define which team is best, but it says it'll proceed by calculating win rates for each conference. And it lays that out for us. And then it finally actually gives us a ranked list here. Now, what you'll notice is it starts with Michigan, which might not be a conference that you recognize. You might think, well, that's a team, right? Let's see what ChatGPT has to say. It's important to note that this analysis assumes the conferences listed directly correspond to the actual competitive collegiate conferences and may include a mix of divisions like FBS and FCS or historical conference names. Additionally, the performance of a conference can vary significantly from year to year. So these rankings reflect the data provided up to the latest refresh date. So it's based on all the data. They're saying change over time. We might want to look at that. Would you like to explore more details about the conferences, or is there another aspect of the data you're interested in? Very nice. And then I guess we can take a look at the data here. Now it does look like the code is slightly different than what we saw before. Still using the group by function, but not calculating as many measures as it was before. It's calculating the number of wins from a home team and away team perspective. It's calculating the number of losses from a home team perspective and away team perspective, and it's looks like looks appears to be robust, calculating the win rate as wins divided by wins plus losses, sorting by that, showing us the top 10 from a highest winning percentage perspective. And when we come back to the list here, we can tell there's some data cleanup that needs to happen. First of all, there are clearly some conferences here that are not necessarily in the FBS. So if we're just interested in FBS games, or maybe games where there was at least one FBS team, or perhaps what we'll do is just look at games where there were two FBS teams. When we're comparing conferences, we might as well just compare games where both teams were from the FBS. That should filter out some of these other conferences like Michigan and perhaps Liberty League and Commonwealth Coast and so forth. So we're looking at the results and we're giving ChatGPT some feedback. I'll say, let's just look at games where at least one, actually we'll say where both teams were in the FBS. Now, I think in our Power BI training to create our dashboard, we took the approach of just looking at games where at least one FBS team was involved. And that was so that if we looked up the record of Ohio State, for instance, we would see a true winning percentage and a true record for them, even some games where they played a non-FBS team. So in this case, though, if we're really assessing the conference as a whole, we may not be interested in games that were played outside of the FBS. Maybe they could be telling. Perhaps they give some information about how you've done when you've played some games from other divisions. But maybe it's something we can control for when we take those out and just look at playing other FBS teams. So let's just look at games where both teams were in the FBS. Now, another thing, we can tell that ChatGPT is struggling with the size of this data set. Do we really want to look at 1936 games, or maybe we just want to look at more recent games? Maybe just games since year 2000, just choosing a number. So let's also just look at games since 2000. Maybe it'll be able to process this a little bit quicker. Now, in some cases, you may want to look further back. Let's see what it comes up with here. To focus the analysis on games where both teams were in the FBS division and since the year 2000, it's going to filter it down in two ways, right? Filter it based on year and filter it based on the home and away teams both being in the FBS division. And it's really neat that it's able to figure out which field to filter on. I haven't explicitly told it that field, but it realizes that in order to figure out whether both teams are in the FBS, it's going to use the division field. It's neat. Probably recognizes that that value FBS exists in that field. I imagine there could be some trickier situations where it could get confused. I would imagine. All right, focusing on games where both teams were in the FBS since year 2000. Okay, now we're getting FBS conferences, it appears. And it starts with SEC, win rate of 57.25%, and it kind of goes down from there. Very interesting. These win rates provide insight into the performance of FBS conferences and games played since year 2000. So it's given us a summary here. And it even gives us a few high-level insights, which is something you should do as an analyst too. You don't just take this table, share it with your stakeholders, and say, here's what you asked for, have fun. No, you call out some interesting stats, and that's exactly what they're doing here. The SEC leads with the highest win rate, followed closely by the Big East and the Big Ten, indicating strong competitive performance in this period. Yeah, I guess when the winning percentages are closer together, shows you there's some, at least a little bit of competition between the conferences in general. It's not just, SEC winning 100% of their games, for instance. Would you like to further analyze? Okay. Well, that was good. Let's take a look at the code here, just to check on it. All right, here's our filters. It's filtering down on the pandas data frame called data. That's what it's called it. Filtering on season, making sure home division is FBS and away division is FBS. And here, because that code needed to come first, it has repeated some of the code from the last part as well. So in this case, it needed to insert that earlier on. It didn't insert the part before that, which would be the import, but it did say, okay, we're going to need to apply this filter and then apply the rest of the code here. It appears to look pretty similar to the last one, after the filter line right here. Very good. And of course, it's got its comments in there too, so it's pretty well formatted Python code. Great. Well, maybe we want to know how this looks over time. Let's ask that question. How does this look over time? And of course, there's all kinds of additional analysis we could do. We could ask it to look at it based on average point margin, or like it said, another metric potentially. Also notice Pac-10, Pac-12 here. These are not combined. They named, and this is pretty impressive. It says now part of Pac-12. It knows that Pac-10 was part of the Pac-12 now. That's really interesting. And so it kind of hints that maybe these could be consolidated. And I bet if we asked it to do that, consolidate Pac-10 and Pac-12, I just have a feeling that it'd be able to figure that out. Maybe that's something that you could try. So maybe ask it to combine that. Pretty cool that it was able to figure out that those are actually the same value. A lot of people would skip over that. Let's see what it did here. It looks like we've got a graph here. And the only downside that I'm seeing is the graph is a little volatile, which is probably to be expected. Conferences have their up years and their down years, although it would be even more volatile at the team level, of course. It's breaking out by year, it looks like, and it is giving a lot of similar colors. It looks like maybe it's using a different symbol, but it's really kind of hard to read this when they're all similar colors, either green or gray. Now it was able to make some observations here, which could be interesting. Let's see here. The plot above shows the annual win rates of selected FBS conferences, since 2000. Each line represents one of the prominent conferences. So somehow it's figured out that there are some prominent conferences here. Wonder how it's done that. I wonder if it's based that on volume of games or what, or just doing some research online, or since it was trained last. SEC, Big 10, Big 12, ACC, and Pac 12. Look at this, including Pac 10 data for historical continuity before the conference transition to the Pac 12. We were just talking about asking it to do that. It went ahead and did that when we asked it to look at this over time. Now, that could be a good or bad thing to make assumptions there, but I think that's a pretty good assumption. So it said, what did it say? Prominent conferences. So I'm sorry if you're American Athletic or Mountain West or FBS Independence. Apparently, ChatGPT doesn't consider them to be prominent conferences. You decide if that's fair or not. But anyway, it's really nice summary there, and good decision to combine the Pac-10 and Pac-12 together. I like it so far. Key observations from the plot include, here we go, SEC consistently shows strong performance across the years, often leading in win rates among the selected conferences. Big 10, Big 12, and ACC display competitive win rates with fluctuations over the years, indicating periods of dominance and competition. I would agree with that. Pac-12, including Pac-10, demonstrates variability in performance, with some years matching or exceeding other top conferences. Visualization highlights the dynamic nature of college football. Well, that's why we play the game, right? With shifts in competitive strength and competitiveness over time, it also reflects the impact of various factors such as changes in conference membership, coaching, and player recruitment. Okay, not a bad summary. Let's take a look at the code behind this latest iteration we've done. So it's selected those conferences and that we talked about. It is doing some grouping by season. It looks like it's recalculating maybe the winning percentage here, and it's using the matplotlib package to do our graph. Very cool. All right, well, there's a couple of things I think we could potentially ask it to update, one being the color. So let's ask it to make each line a different color. You know, another thing is that it tends to be quite volatile here. Maybe not too bad, especially since they just show selected conferences. I kind of like that they did that because it would probably be too busy with all the conferences. And you do see, you know, it's hard to tell which conference is which. This one seems to be consistently low. Uh, you know, but it probably could be aggregated a little bit. So maybe we could aggregate, I don't know, maybe every 5 years together. A lot of times when you group, when you summarize, you start to find more meaning in the data than you do when you get really granular. Or imagine doing this even by week of the season, then it'd be really hard to read. So you've got to summarize your data at the right level. And if you do it too high level, you know, like every 10 years, for instance, we'd only have 2 or 3 data points here. So you got to find that right balance. And then maybe if you do find an interesting trend, you drill into it a little more. That's data analysis for you. So make each line a different color and perhaps aggregate the x-axis by every 5 years. Now I'm kind of curious what it'll do here because we went with year 2000 through mid 2023. You know, what's it going to do with that partial year? I would imagine just start with 2000 to 2004 and so forth, and the last data point wouldn't represent a full 5 years. But we'll see how it handles it here. Okay, so it's summarizing that it's going to ensure each conference slide is plotted in a different color. I love that it kind of gets why we're doing this for clarity. That's right. I want to be able to see the difference. It would have been nice if you did that in the first place. But then also it gets the aggregation by 5 year to smooth out short-term fluctuations. It gets why we would want to aggregate too. That's really cool. It's understands some of these general data analysis principles, at least these two. So I'm pretty impressed by that. Okay, the result came back here, but it apparently ran into an error a couple times. Attempted to aggregate, something happened, might be due to the complexities involved in aggregating the data properly. But they do note how to approach it here. And in fact, it looks like there's some code here. They're saying we want to aggregate every 5 years. Makes sense. We've got some code to do that here as well. I like it. Um, and then after that, it mentioned looping through to get a different color each time, and it looks like it's doing that down here. So it seems like it was able to do it, just kind of timed out, it looks like. Now, in situations like this, sometimes you can say, try it again. Or in some cases, if it tells you it can't do something, you can ask it, I want you to do this, or use the internet if it needs the internet to do that. Probably not relevant for analyzing data here, but I'm going to have it try this again. I've seen a few cases here where it just tends to time out. It takes a while to process it, especially probably with these, what it considers to be larger data sets, you know, few 1,000 rows, 10,000 rows in this case. Well, we ran into an error again here. Seems we've ran into persistent issues. Okay, so it's really struggling with this. But again, the code that it came up with looked pretty good. So maybe you copy this into Python from there. Don't know why it's running into this. And that's exactly what it's suggesting here, using an external data analysis environment such as local Python setup. Yeah, and just use the code that they've come up with. All right, well, let's maybe try something different. It's really struggling with this graphing request we gave it. We finally stumped ChatGPT from a data analysis perspective. Um, okay, let's say we just want a ranked list of conferences. We're going to give it a little bit more of a challenging data analysis task here. Not necessarily a straightforward request either. But this time, so before we had it ranked by winning percentage, but this time we want the ranking to factor in strength of schedule. Maybe the SEC just plays easier teams. Yeah, let's find out. You know, another approach here when you're comparing conferences could be to remove games played within the conference, right? Those would potentially not be relevant. But I guess your conference winning rate is 50%. So it kind of dilutes that. It would almost be interesting to look at these stats for outside of conference games. And what we'd probably see is even more dramatic differences. Maybe something we can ask Chat GPT to do here to see that. Let's see what it says. Factoring in strength of schedule when ranking conferences introduces a more complex analysis. Absolutely. Here's the general approach. And so it gives us a few ways that we could do that ourselves. ChatGPT likes to do this, tell you how you can do this. And sometimes if it doesn't do it for you, you can follow up and say, no, I wanted you to do this for me. So it's looking at each team, calculate the win-loss record of its opponents, which is a great way to handle strength of schedule, at least to start off with. And then you could look at the win-loss record of your opponent's opponents and just keep taking that to the next level. In fact, we have a predictive modeling training, a data science training on our YouTube channel, and you can learn data science in Python through that training. But what it does is it builds a college football prediction model. And one of the things we do is build a feature variable that is considers the win-loss record of a team's opponents as well, and even their opponents. It just keeps, you can go with that as many times as it makes sense, and you're still seeing value of looking at all those opponents' records. Okay, in this case, I ran into another timeout issue. I think this could just be a computer issue potentially, although it is web-based, but I'm running into a lot of errors here. Sometimes in order to get ChatGPT to finally show you what it's been doing, you have to go and refresh your browser. I've had that issue recently. But it struggled to complete the task here. And even if I look at the code is clearly incomplete as well. Well, let's maybe try one more thing. Could you create a model that predicts how Ohio State would perform against Michigan? We could probably be more specific here and say, are they predicted to win? What's their likelihood of winning against Michigan? Or what would the expected point margin be against Michigan if they were to play them now? So I could give it a little more detail. Let's just see what it comes up with. We're kind of moving from a visualization to an analytics methodology when you think about considering strength of schedule. And now we're going to ask ChatGPT if it can build a predictive model for us and just see what it comes up with. I have a feeling it's going to start off with something like, building a predictive model is a complex task that requires, and they'll probably tell us what we can do. I'm just taking a guess here. Creating a predictive model to estimate the outcome involves several steps: data prep, feature selection, model training and evaluation. Okay, that's not bad. Kind of walking us through the data science process. Given the complexity, factors such as team statistics, historical performance, player injuries, ooh, that's a good one, and home field advantage absolutely should ideally be considered. However, with the data we have, we can create a simplified model. MVP approach, something I highly recommend. Just use the data you've got to do the best you can based on historical game outcomes and perhaps consider some team statistics. Okay, and it's laying out each one of these. Given data set and tool limitations, let's start with a simplified approach where we analyze historical matchups between Ohio State and Michigan to gauge their performance trends. Initial analysis can provide insights without the complexity of building a predictive model. If detailed statistical data is available, a more sophisticated model could be developed externally using tools like Python scikit-learn library. That's a very popular library for using building machine learning models. That's one that we use for the random forest model in our college football prediction training. Would you like to proceed with an analysis of historical matchups? I'll say, no, I want to use this data set to build a predictive model. So again, sometimes you got to reinforce the idea. Doesn't always work. We'll see if it happens. We'll focus on creating a simplified model to predict the outcome of a game between Ohio State and Michigan. All right, so use feature selection, use historical game data between Ohio State and Michigan. You know, there's something in modeling called bias variance trade-off. And reducing bias and reducing variance will generally lower your error, but there's usually a trade-off. The trade-off it's making by focusing just on previous Ohio State-Michigan games. It's a very low bias approach, very relevant to predicting an Ohio State-Michigan future game. But you miss out on all the other games between other teams, and you might be able to get some meaning from those. Sure, they're less relevant than Ohio State versus Michigan, probably, but you're going to have just a smaller set of rows. We've, in fact, told it to just look at games since 2000. You probably have 23 games to learn from if you're just looking at Ohio State, Michigan games. That's very high variance, and that's going to hurt your model's accuracy. So I don't like that decision that ChatGPT made here. Um, Again, you could try it both ways and see which one does the best on a holdout data set, but that is just not enough records to build a model on. I would much prefer to use all the games and maybe have some special variables for Ohio State, Michigan, perhaps. Features might include the win-loss record of each time up to the game. I like that. Average points scored, average points allowed in the season up to that game. Outcome could be binary win-loss or the point differential, Ohio State points minus Michigan points. I like that target variable. Two very good ways to do that. Look at this model type, a logistic regression model for predicting win-loss because it's a binary indicator variable, a linear regression model of predicting the point differential. It gets that you use a linear regression for a continuous variable like point differential and a logistic regression for binary target variable. That is excellent. That is really cool that it knows that. All right, data prep, filter games between Ohio State and Michigan. Again, would not recommend that. Think about some of these features that you could learn from, not just with Ohio State and Michigan matchups. You can look at their win-loss record of any two teams leading up to each other to learn how the win-loss rate impacts the outcome of a game. But you don't just need to look at Ohio State and Michigan for that. Again, you could have that as maybe one variable. What's this historical matchups look like in the past? But bringing your modeling data set just down to Ohio State, Michigan games, that has got to be way too high variance wise. Okay, calculate the features, of course. Given those constraints, we'll start extracting the relevant games and preparing the data set for modeling. And then it's going to town here. And this is kind of cool. While it's analyzing, you can actually see the code it's been creating. So far, it doesn't look like it's done much. I'm going to refresh the browser. This is what I'm talking about. Sometimes at least right now, mine is getting frozen. And so I'm not sure if that's a Chat GPT thing or maybe something on my side. Okay, so I think it was processing, and it looks like it finished. Let's check out the code here. So here's where it's filtered down the games to cases where the home team is Ohio State or Michigan and the away team is Ohio State or Michigan. For simplicity, we'll create a binary outcome variable for Ohio State winning. Okay, it's factoring in home versus away team. Appears to be okay there. Point differential. Select the relevant features. So it's looking at season, OSU win, point differential. Okay, that's it. That is no model here. um, I think the code didn't complete. So you've got to keep an eye on the code. And here's the thing, sometimes it'll just time out. That can happen. The other thing that can happen is sometimes it does miss things. I mean, it's really impressive the degree of um, data manipulation that it's done and kind of assumed, like taking into account the away team and home team's perspective of games. So you're not just looking at a team's home games or a conference's home games. You're looking at both, and that requires extra data manipulation. As we saw when we looked at the Python code, grouping conferences together, all of that is really impressive. But sometimes ChatGPT doesn't always do that. I've seen it take averages of averages, for instance, which instead of a weighted average, so that can throw your analysis off. And you could see it uses Python for data analysis tasks, so it's going to be helpful if you know Python. But even if you don't, Python's a relatively simple language. We do have a training on it. But if you don't, a lot of times you can at least look at the code, look at the comments, even outside of the code, just the approach that it's taking. Make sure that's robust. But even then, that could look robust, and then you look at the code and see that it was maybe miscoded something. So it is helpful to kind of look at the code. And fortunately, you don't have to write the code. You just kind of have to read it and get a sense for how it's working. But it's really, really important to check that if you're going to use this for analytics. Well, this is kind of neat. It's actually embedding the code directly here. So it's not just the endpoint that has all the code together. It's showing you, here's how we would prepare the outcome variables. Model selection here. Yeah, so it looks like it decided to use logistic regression, scikit-learn. Really cool. Now, what features is it using? It's calling it feature one and feature two, and it says replace with actual features. Okay, they're not going to do any feature engineering for us, I guess. Again, I'm sure we could ask a follow-up and ask it to code out some features for us. And it's going to assess it looks like it's going to assess the model for us on a holdout data set. Did it create a holdout data set for us? Um, Yes, it did. It used the test train split to create, basically this is your input variables for the training data set and your input variables for the test data set, and likewise for your target variable, which is whether OSU wins or not. Not bad at all. The only thing is it didn't create any features for us. Let's see, did this create, yeah, looks like this might, I was hoping it would consolidate all the code for us, but it doesn't look like it did. So we would need to take the code from each one of these sections. Not too bad. Let's just see if I can ask it. Can you create some feature variables for me? And I'm not telling it which ones. Again, the more direction you can give it, better. So if I wanted to say, I want to look at their win rate leading up to that game, can you include that in the data set? That might be even better. creating feature variables for predicting the outcomes of games between Ohio State and Michigan can involve several aspects. Their historical performance, absolutely, win-loss records, and then you got to think about things like up to the just that season, or things maybe even prior to that season. It could be relevant. Average points scored and allowed, home advantage. Okay, and so it's starting to do some things here. Okay, it's created this prepare features function here, and it takes in a team and a data set. I'm not sure why we can't just pass it in a team, because it looks like this data set that we're feeding it for Ohio State is simply the original data set filtered down to Ohio State. So this seems like this line could be maybe the first line included in this function, but I might be missing something. Uh, so you've got your data set, it's sorting it by date, and then it's calculating cumulative wins, losses scored. So it's using the cumulative sum function here from Pandas, I believe. And it's calculating it. So I guess we'd end up with a data set that's maybe one row per game that we could join back to the original data set. And up until that point, here was their record, perhaps. And so this could work, but it's even telling us ourselves that, hey, you need to repeat this for Michigan and probably do some more things. And so it's left on us to kind of finish the model. It gives us some helpful functions, but there's still quite a bit for us to do. Now, it'd be nice if it just did all of this for us, even ran the code for us. So from here, I might ask, could you consolidate all of this into one piece of code? I'm guessing we're going to get a message like we did here that that's too much for ChatGPT to handle, the execution constraints. We'll see. Actually, certainly that's promising. Below is a consolidated example of how you might calculate and prepare feature variables. Okay, so it's starting even from the loading of your data. I like that. It took the very first place we started with, importing our data there. And then prepare team features. Okay. Calculating the points scored and all of that. This is our target variable here, whether the team won, appears. Okay. Now, are we going to eventually get to the train test code? We'll find out. Okay, so it kind of stopped there and it never actually included the model training part. So maybe I provide further clarification there. I mean, I want you to include all of the code, even the model build part. See if that helps. All-inclusive example. All right, let's see it. Well, it's importing all the packages at the top of the code. That's good. Has our import placeholder here. I'm not really sure why that's coded out. Maybe they don't know where the data set's located, so they want to keep that commented out, I guess. But they're preparing features, and they've got a whole function set up there. Not a bad way to set it up, really, with a function. I like that they've set this up as a function, so it's very flexible. This is kind of what they've done already in the last example. Splitting for testing and training. That looks good. Not really sure why they commented this out, but not this part. Maybe they will. No, there's just some things are commented out here and some things aren't. Okay, and then you train it, you get some predictions, evaluate the accuracy. Okay, replace it with, at least it's telling us that we need to make some updates here. Okay, so it's a template that we can go to Python and run. Let's just try asking it to run it for us. I want you to run this code. Oh boy, given the constraints of our current environment, we're back to the environment constraints, whatever those are. So it looks like we're not going to get ChatGPT to build a model for us. Maybe we could try asking it to trim down the data to even fewer years. Maybe it's a data processing limitation, all kinds of things you could try. Well, that's our tutorial on ChatGPT. I hope this was helpful. On the positive side, we saw ChatGPT make some really good assumptions and call those out in case they weren't. On the other hand, we saw some processing issues. We saw that it's not always able to analyze large data sets. There are sometimes ways around those, like sampling down. ChatGPT did a great job of making recommendations on how we can maybe get around those processing limitations. We saw some cases where we needed to refresh the page or ask it to refresh it again. It created some pretty good starting code, especially when you get to the predictive modeling side of things. Not too complex, but something that maybe could get us a good start. Wasn't always able to run the code, but at least it set up the code for us. You do need to be careful. Every now and then, ChatGPT can make some maybe not ideal code, again, taking averages of averages. And then in other cases, it'll do just fine. It'll create a weighted average. So I highly recommend checking the Python code. Again, we have a training video on Python on our channel if you're interested in learning Python. It's a relatively high-level language that's one of the easier ones to learn. But even if you don't know Python, just take a look at it. Usually you can kind of read it and kind of follow and see the general idea of what it's doing. And if there's something that just doesn't make sense there, you might need to ask ChatGPT to maybe, hey, this should be a weighted average. Why don't you redo this and make it a weighted average and check the updated Python code. So hopefully this was helpful to show you what ChatGPT does well with and what it doesn't do as well with. If you enjoyed this video, please consider giving it a like. And if you'd like to see more ChatGPT and analytics and data science and leadership trainings, please consider subscribing to our value-driven analytics channel. And if there's anything else we should know about data analysis and ChatGPT, maybe some interesting things you've discovered, please feel free to leave a comment. Remember, don't feed your personal or sensitive company data, really any company data, to ChatGPT unless you've checked with your IT team, checked with your manager, and most likely if they're going to say yes, it's because you have the enterprise version that doesn't train on your data. So make sure that's in order before you even think about feeding it personal or company sensitive data. On the other hand, if you're using a public data set like we did today, you should be just fine. Thanks again for watching, and I hope to see you in the next video.